Hey guys, this is the first tutorial made by us Dokai. It is part 1 of a series diving into road creation using Houdini. During this tutorial we will tackle the problems which arise when dealing with intersections. Without further ado, let's jump into Photoshop to go over the basics. Let's start with describing our intersection. Initially we have 3 lines, roads, coming together to form our intersection. And then I'm gonna draw the geometry we are going to be creating. So basically the geometry of the intersection itself. And first divide it up because we don't really need the straight pieces at the ends and we only care about the intersection itself. For the straight pieces we will just be using a sweep. We need 2 variables to create this intersection, the length and the width. So the length, pretty easy, it's basically the length of the intersection, and the width, that's basically the width of the road. With those we can now construct our final curve. I'm gonna color that in green, and that's basically the outer edge of the intersection. Now we will be creating our test geometry. Place down a few curve nodes and put them together with a merge. Then go into your top view and let's draw some nice lines coming together. After this we will be placing down a fuse. This is just to make sure we have one nice intersection point. That's what we want. Cleaning up your input is usually one of the bigger tasks out there. Here are a few tricks. So we have a convert line that is going to create some loose primitives out of our geometry. Then place a polypath. It's a small node and that basically connects them again. Helps to create some clean curves. And after that a resample. Depending on what kind of roads you want, you might not want to do this, but I'm going to turn on subdivision curves to create a little bit more round curves. When we look at the point numbers of our curve, we can usually see some kind of direction. Right now they are all going basically, well, they're not all going to the curve. So this one starts low, ends high, and here it starts high, then it ends low, and here it also starts high, then it ends low. That's usually not really what you want when dealing with these kind of intersections. You want them all to go into the same direction. And there might be issues with having multiple intersections. So there's a fix for this. First, let's place a reverse node. This will be reversing the curves. And then place a merge again. Now, with those together, we are going to place down a carve. And with this carve, we're gonna put the first U to 0 and the second U to 0.5. And now we don't have, we basically doubled our primitive number. Let's also place a fuse. But what we know now is that the inner primitives of our intersection all point towards the same direction. And that's important. Next up, we want to select the intersection. Let's place down a point wrangle. And how we are going to select our intersection is the following. First, we need to know the neighbor count of each point. So make sure your point wrangle is also set to points. You can always check if this is working by making an attribute out of it. And as you can see, it works. And we can see that our point 0 has 3 neighbors, which is correct. And we don't really care if there are more roads coming in, so we're just going to say if there are more than 2 neighbors, then it's going to be an intersection, and we're going to be declaring it using an attribute. Now you can see that all the points have the value 0 except the intersection point, which is a value of 1. And let's make an integer out of this. Now I want to promote this attribute to primitive. So these entire primitives, you can see over here, all will be connecting to our one intersection. So that works, that's nice. Make sure you take the maximum value, because that's what we want. We want to know which primitives are part of the intersection, and all the other pieces are going to be 0. Now, to make sure that we only select the intersection, let's place a delete node, delete by expression, and delete all primitives which have an intersection ID of 0. Next up, we will be selecting the length of our intersection. It was the red line you saw in the beginning of the video. To do this, we first need to measure our primitives to see what length they are at. Place down a measure node, make sure it's set to parameter, and now you have a nice length value for each primitive. Place down a primitive wrangle, and let's create our carve value. Let's create a parameter for this. And now you can see our custom carve value. We want to cut off our primitives so they have the exact length which we want to have for our intersection. There are a few problems when doing this. We can place down a carve node, and here you can immediately see that if we have only one value, it's basically between 0 and 1, and it means or you're taking the entire curve or that part of the curve, basically 1 divided by your carve value. That's not what we want. We want to have a certain length, and this length has to be, well, probably sometimes it's different per primitive. So how are we going to do this? Well, at first we can delete the carve node, because with the carve node it's not that easy to carve each primitive with a different length. So we're going to dive into Vex for this. Place down another primitive wrangle. I found this solution on Adforce. It's basically like a simple carve which you can use per primitive with different values. Now you can see that our carve value is basically the length which we need to put in. That's our length attribute. So let's change this one to length. As you can see right now, it's a little bit too large, so let's scale this one down a little bit to 2 and this one to, let's say, 0.5. That's the beginning of our intersection. We want to select the points we've just created. So those are 0.5, 6 and 4. An easy way to select these points is to just take the highest point numbers for each road segment there is. Let's place down the point wrangle. First we need to point limit. Then with the if statement we are going to select all point numbers below this point limit. And we will be removing those points. Now we have our segment points. But first let's add some orientation attributes. I'm going to be doing this using a polyframe. If you don't know the polyframe, it's a very handy node which is just incredibly useful when trying to create orientation attributes or cleaning up your curve. And let's set the tangent name to be n, our normal. As you can see, my initial curves have normals right now, but the points I created as the outer second points, those don't have normals. So we need to be giving them some normals. We will give them the normal of their neighbor. So, they have normals. I also want to know where my original intersection point was. So, let's get that one. Get this off, delete original. Place another delete node. Set this to points, delete non-selected. And there is our initial intersection point. I'm not always certain if the points are radially sorted here, so let's just add it in there. Wire the segment points into the left one, and then after that wire in the intersection point. Whenever you want to do a radial sort, there's a nice little trick to do this in 2D. First we need to know around which position we want to do a radial sort. That's the point position of our intersection point. Second input position, and there we go. Then you need to subtract this from the original point position. Place a vector to float. Search for the arctangent. Wire in our X and Z component. And that is going to be our sort value. So place a bind export. After this, just place a sort node. Set this to attribute sort value. As you can see, we still have our width attribute, and we will be using that right now. Place down a attribute promote. Set this from primitive to point. Now it gets a little bit abstract, but don't worry, it will all come together in the end. We're going to divide this up into 3 segments, one for each outer edge of the intersection. Place down a for loop and make sure it runs over points. Now you can see we have our first point selected, but we also want to select the second point. Copy our repeat begin. Make sure you set it to fetch input. Place down another point fob. You could also do this in wrangles, really doesn't matter that much, whatever you like. Press create meta import node, wire that one into the second input and the repeat begin into the first input. From the meta node we can get a iteration value. Type in import detail attribute, set it to second input. We're going to add one value to our current point number. Place down a modulo and wire in the total amount of points. Place down a compare node. Make sure this is set to integer. So we have our total number of points, which is 3. We also have this looping around over all points separately, and we're adding 1 because our total amount of points is 3, and I want those to line up nicely. Then we have an iteration value, which is per iteration. It's also going to change. And basically this will give us a number which is 1 the moment we select the second point. And we want it to be 1 when we are not selecting the second point. So let's turn this to not equal. Place an if block. Get the current point number. Place down a remove point. But this error sometimes happens. Don't really worry about it too much. Let's make sure we have this set to integer, same as this one. Make sure you're selecting the iteration in your import detail node. And if we place down a merge now, and if we set down a merge now, you can see we're always selecting 2 points. Set this to single pass, and if we go through this, we keep selecting 2 points for each iteration, which is exactly what we want. Let's make our intersection point gray. There are 2 curves we're going to create. One is the inside curve and one is an outside curve. Let's start with the inside because that's the easiest one. Place down a point fob. Let's make sure this one is set to detail. We're in the merge as first input, and let's create another fetch input node. This one will get us our intersection point, which is going to be our second input. And dive in. In here, we're first going to get the location of our intersection point. We do this the same way as last time. Make sure it's set to second input. As you can see, it doesn't matter if you're using the op input 2 or you just it doesn't matter if you're using op input 2, drag it into file, or just set the input to second input. Doesn't really matter. Let's create a point where our intersection point is, and let's place two constants which have the ID of our previous points. Now we want to create a primitive. To do this, type in add primitive. Let's order these nicely and place down 3 add vertex nodes and wire all those in. In this one the order is important. As you can see, we now have a nice primitive. Let's call this inside curve. Let's place another detail fill. Make sure it's set to detail. And let's just call this outside. Wire in the same nodes. Let's dive in there. This one is going to be a little bit more tricky. For this we're going to need the normals. Because what we want to do is to not use the original points to create this curve. We want to offset them 90 degrees away from their normal. There's a nice little trick to get you that direction. Type in cross product. Wire in the normal. And make sure the second one is set to a up vector, which is 0, 1, 0. It already automatically does that for you, which is nice. If you wire this into the normal, nothing will happen because we're still in detail mode. Let's set it to points. And now you can see we have a nice 90-degree angle. Let's switch it around a few times so you can see the difference. And let's get back to our detail mode. Now, we want to select the normals of our 2 points. So let's place down 2 constants again. One for point 0 and one for point 1. Then we need to get the normals. Get attribute, wire in the constant, set the attribute to normal. First input, it's a vector, and we want to access a point attribute. And do this also for the second point. Then wire in this cross. Then wire it into a cross product. Let's copy this one. As you saw, we need to negate 1, which was, let me get that real fast, point number 0. So we need to negate our direction from point number 0. We need to get the width. Let's type in get attribute, wire in our point ID, 0 in this case. Let's type in width, floats, first input, it's a point attribute, so that's nice. And we want to multiply this with our direction. We want to do the same thing for our other point. Make sure you're first inputting the vector and then the float, so the outcome will also be a vector. Now, finally, we need to get the position. We need to get the original position of our point. Let's get the position of both points. And let's add these values together. And let's add a point. Let's add 2 points. As you can see, one is not working. As you can see, one is not working, and that is because I forgot to get the new normal. And now it does work. Now, to create our final point, which contains both offsets, and it contains the initial position of our intersection. So let's get attribute, the position of our second input. It's a vector. It's the first point, so we don't really need to bother about that one. Throw it in there together with our offsets. Don't mix those two around. You want to use the outcome of the multiply, because it's the direction multiplied with the width, not with the added position of the initial point. Place a point. That has our final point position. First, remove our old points. And we're going to do the same thing as in the other node. Add primitive, add vertex, And let's copy this one 2 times. And there we go. Let's place on merge just for visualization. This is the first core of our intersection. Next up, we will be adding UVs. If you don't really need UVs, then you're done way sooner. You can skip that part. Let's delete the merge again and place down 2 resamples. Also, we are going to place down a control node. Just place down a null. Let's call it control. Edit parameter interface. Add a float. Call this resolution. Copy parameter. And let's throw it inside of this one. And let's throw it into the resample. But first, let's do a little bit of a cleanup. Place down a polypath, a sort, which sorts by vertex order, and a convert line. Right now, it's very important that we have 2 primitives instead of 1. So when we do our resample, it does both of them separately and we keep our middle point. Let's throw down it a little bit of a higher resolution. This one should be division size, not resolution. For the other one, place down a polypath. Just copy over the polypath and the sort. You don't need to convert line for this one. That's actually important. In the resample of the outside curve, you want to be setting it to subdivision curve. So you get a nice and round edge. Create a spare input. I always like to use spare inputs because if you want to compile our system and you have all these loose channels going everywhere, that's just really annoying. So try to get used to making lots of spare inputs so everything is compilable. And throw in the first resample. And let's set this to a relative path. And we're not going to use the maximum length, we're going to use a maximum of segments. Endpoints, putting down -1 because we have a spare input. And that will give us the amount of points. Now we don't need the exact amount of points because at first you can see over here there's a double point over there. So what we need to do is to subtract 2 points. And now we have the correct segment amount. Place a fuse after the first resample. And now you can see 17 points, highest number of 16. And the same goes for the other curve. In our first resample node, make sure you have this curve view attribute checked on. You can see the curve view attribute going from 0 to 1, and again 0 to 1. Although this is not exactly what I want it to go from 0 to 1 and then from 1 to 0. So let's fix that. Let's place down a point VOP. Don't place a fuse yet. Then place down a multiply constant. Let's multiply the total amount of points by 0.5, keeping an integer number. Place down a compare, wire in the current point number, and set it to greater than or equal. Place down a bind node, and then if block. Out of our compare comes the condition, and our bind becomes our curve view attribute. Place down a complement, 1 minus x, and finally place down a bind export. Set it to curve view again, and wire the complement into the bind export. Now we have our values going from 0 to 1 and from 1 to 0. Place down a fuse. Let's attribute copy the curve view attribute to the other line. from points to points. Attribute is curve U. Don't match the position. And now we have another nice curve U attribute. We have the U attribute, but we don't have the V attribute yet. Place down the point wrangle. Set the curve V attribute to 1. Set the curve V attribute for 1 for the inside curve. And set it to 0 for the outside curve. At this moment you want to merge them together again. With an add node we're going to replace our curves. Delete geometry but keep the points. And create a primitive by group. Close this one. Also, one thing to make sure of, if we go into our perspective viewport, if you go into display options, you can remove back faces, so you always know which side is facing up, which is a very nice thing to know. For now, I'm just going to ignore it. Place down a polyfill, and finally a blast, and delete primitive number 0. Now we have clean looking geometry. Normals are not there yet, so let's create our normals. There we go. So let's place a quick shade. Here you can see the intersection you've just created, looking nice and clean. Now to finalize the UVs, place down a point fob. With a bind, get the curve U. And also get the V attribute. Photo vector. Bind export. Set it to vector. UV. Place down an attribute promote. From points to vertice, UV, place down a fuse. Make sure you have your quadrilateral grid turned on. Let's have a look at those UVs. Right now they look a little bit mirrored. Also there's a little bit of distortion. Placing down a subdivide usually fixes this. Let's do the fuse after the subdivide. Also make sure in your subdivide that your crease weight is very high, so we're not getting those weird silvers in there. And there you go. These UVs are mainly designed to tackle a certain amount of distortion. I have multiple UV sets in another version, which will be there in a later tutorial. As you can see now, we have a very fast intersection solver, which also works in 3D. Alright guys, that was part 1 of this series. We hope you have learned something, and if you enjoyed it, make sure to follow us online for some more cool game dev stuff. For now, this was Dokai. Bye bye!